And now we get to the part where we actually talk about the random forests. So a random forest is a supervised machine learning technique which can be used to solve classification or regression problems. And that shouldn't really be a surprise because, as we've mentioned, the random forest is just a collection of decision trees, and this is the description of a decision tree. So of course, that description will also work for the random forest as a whole. The random forest utilizes what we call ensemble learning, and does this by combining the output of many decision trees to make the final prediction. And because these decision trees are largely independent of each other, that means that using a random forest is equivalent to asking multiple independent experts the same question, whereas using a simple decision tree is equivalent to asking just one expert who may even be overly confident in his answer. And we use a specific type of ensemble learning called bootstrap aggregation, also sometimes called bagging, which I will get into the details of in the following slides. So the first step in the bootstrap aggregating is to bootstrap the data. And bootstrapping the data means that we randomly resample the data with replacement to make new data sets. So in this case, I've made a little data set here with 5 observations without mastitis and 5 observations with mastitis. And we have the actual real variables. We have the days in milk, and we have the standardized forecast errors of the milk yield, conductivity, fat, protein, lactose, somatic cell score, and blood that we get from the dynamic linear model. So we can take this data and bootstrap it by randomly resampling it with replacement. So when we do this, we create a new data set with the same size, but where we have randomly selected the rows. And because we randomly select the rows with replacements, some of the rows will be in the same data set more than once, and some of the observations will not be in the data set at all. And in general, when you resample the data set in this way, where you create a new data set with the same size based on random resampling, on average, approximately 1/3 of the original data are not included in the resample data. And the algorithms that we use for training the random forest can make use of that by testing the individual decision trees on the rows in the original data that was not used to create a given tree. And that makes the training algorithm able to actually estimate the accuracy of the overall random forest. And in R, you can even get this estimate. It's called out-of-bag error. And this out-of-bag error is actually not particularly useful for the way that we are using random forest in this course, because we are working with heavily skewed data where we have many more observations without mastitis than observations with mastitis. And then the out-of-bag error isn't as reliable and useful. But it's good to know that it is there nonetheless. So once we have resampled our data, we use one resampled data set to create one tree. And we do that in the same way that I showed you with the decision trees before. So the first step is to select a number of random features that we use to identify the root node. And notice here one difference from the example I showed you on how to grow a decision tree, that we are not considering all of the columns. We are only randomly selecting a few of them. And the default is to use the square root of the number of features that you have. And in this case, we have 8 features. The square root of that is about 2.8. So we are rounding that to 3. So we are selecting 3 random features. And from those 3, we are selecting the root node. Okay. The second step is then for each of the internal nodes resulting from the first split, we again select randomly 3 variables and select which of these 3 variables is the best for making the next split. And we repeat this process until some stopping criteria is reached. And because we are doing it in this way, the various trees in the random forest will be largely uncorrelated with each other, which means that, again, it will have the effect of asking the same question to multiple different experts instead of just many copies of the same expert. So imagine now that we have created 4 different random forests based on the resampled dataset. And imagine now that we have a new observation that we want this random forest to predict. The trees that we created together form our random forest, so we send the new data into each of these trees, and each tree will provide its own output. And here we are asking, does this cow have mastitis? And we'll see that 3 of the decision trees believe that yes, the cow does have mastitis, and 1 believes that no, the cow does not have mastitis. So then we aggregate these outputs, and that's where the aggregate and bootstrap aggregating comes from. And we can see that the aggregate answer is the yes class, the cow does have mastitis, and we are 75% confident in this answer.